I am going to explain some important points related to this chapter. Now, first question, different students have some problem with this question. Solid CO2 is called a dry ice. So, the answer is very simple, that the molecules in carbon dioxide solid state, that is dry state, are loosely bonded, and as a result they very easily are converted into gas without going to liquid state. Once again I am repeating, in case of solid carbon dioxide, which is called a dry ice, there is very poor force of attraction between the molecules, or we can say the intermolecular forces are very less, very poor, and at the room temperature the molecules, they are directly converted into gas without going to liquid state. So this is the reason behind the question, that why solid carbon dioxide is called a dry ice. Or you can understand that it do not wets the surface. It do not wets the surface of the vessel or the place where it is kept, and so it is called a dry ice. Now I am going to explain the second very important point on putting a drop of acetone or alcohol or petrol on our palm. We feel sensation of cooling. This is also very important point, very simple point. Actually, all the organic compounds like acetone, we may say nail polish remover. Nail polish remover is nothing but it's acetone. So acetone or alcohol or spirit or petrol, they are highly volatile. They are highly volatile, and when we put a drop on our palm, then or any surface, then for the evaporation they take up the energy from the surrounding area, and as a result, as the energy is taken up by the drop, for what? For evaporation. They undergo evaporation, and as a result we feel sensation of cooling. Suppose we put, or I put one drop of acetone or petrol or spirit or any organic solvent at this place or any place, then it will take the heat from the adjoining area, and as a result we will feel sensation of cooling. This is one. Now on the other side, suppose we take bath. We take bath, and in this process we have cooling. Why? Because nowadays the temperature is slightly low, and as a result, if water is normal condition or from the tank, then it has also the low temperature, and all the liquids have the tendency to undergo evaporation, and hence the water which we put on our body takes up the heat from our body or the skin. Then we have the cirrus, like this. So this is the point. So this is the case. Now third point, that the water kept in an earthen pot or matka is cooled. It is also there. You must be knowing, any earthen pot or matka or surahi, or sakura, small, small. So their design, their construction is such that they have very large number of microscopic pores. Microscopic pores means very minute pores, and when water comes out on the surface in very small quantity, and on the surface there is the evaporation of water. As I have said, all the liquids have the tendency to undergo evaporation, and as a result the temperature of the adjoining area is taken up, and so the water inside the earthen pot or matka or surahi, it is lower down. It's very simple. The simple explanation is that water kept in the earthen pot or matka comes out on the surface, and at the surface there is the evaporation of the water, and as a result the temperature is lower down outside the matka, and as it is very close, and so it is also cooled down. You can touch the surface of matka or surahi today itself at your home. You will notice that it is cooled. It is always cold than the water itself, and as the process is so, it keeps on cooling. And other point, just nothing to do with this, you must be knowing that after a few months the earthen pot or matka is unable to cool as it was new one, because water has lot of salts. Water has lot of salts, and the salts, they block the microscopic pores, and as a result the water is unable to come out properly, or no water. If you keep for 1 year, so no water, and so there will be no cooling or very little cool. So this is the point about this earthen pot. Now you know about the diffusion. So diffusion is the property I have explained so many times. So diffusion is instantaneous mixing. Instantaneous mixing of the particles of a substance from its higher to lower concentration. Higher to low. This is higher concentration to lower concentration. Now this is diffusion. The point is instantaneous. Instantaneous means sudden. So it is taking place on its own from higher concentration to lower concentration. Suppose we put a drop of perfume at one place, then within few minutes, if all the windows, if no fan is there, so automatically throughout the room we can feel the smell, or we notice the smell. Why? It is because of the property of diffusion. At the place where we have a drop of perfume, or we have lighted an incense stick, so here at this place the concentration is maximum, and then after some time naturally it will go. Why it will go? In order to equalize the forces. Here the force is very high between the particles, so they will try to disperse each other, and so this is the point about the this diffusion. Now diffusion is unaffected by gravitational force of attraction. Diffusion is unaffected by gravitational force of attraction. It may come from top to bottom. If we burn incense stick at the first floor or second floor, we can smell even at the ground floor. If no air is there, because of the diffusion. Diffusion is not affected by the gravitational force of attraction. And diffusion depends on the speed of air. Diffusion depends on the nature. Diffusion depends on temperature also. Temperature also. If one more question related to this point is, if we cook something or if something is being made in our kitchen, then we come to know easily without going to kitchen. The smell scatters throughout the room, throughout the building, throughout the area, because the hot food is made at high temperature, and as a result the particles have more kinetic energy, and particles can move very easily, and hence we are able to know what is being cooked in the kitchen without going to that place. Opposite to that, if someone is having the cold food materials, ice cream, in some other place or even at that way, we are unable to know who is eating or someone is eating. Why? Because in ice cream or any food material the temperature is low, then it will not be have the particles more kinetic energy, and so we are unable to take this point. So this is the point of diffusion. Now other point is the compression. Compression is the property of some substances due to which they are confined to a small area. It is the property of some substances due to which it is confined to a smaller area. Like we take, this is cylinder. Cylinder is just cylindrical structure, and if we have the piston here, this is called as piston, and if we apply here force, what will happen? It will move down. And it will move down. Why it will move down? Because we are forcing, we are pushing, we are applying force, and the volume will be reduced to half. Why? Because of application of force. In case of gases, the distance between the particles, distance between the molecules is very large, and on applying pressure, the distance is decreased, and so this is called as compression. You know the examples of compression: LPG, CNG, dry ice, they are all made by compression. And compression is done at high pressure and low temperature. So these conditions are for making any useful product. So this is compression. Now coming to evaporation. Now evaporation is the property due to which a liquid is converted into vapors at any temperature other than the boiling point. So evaporation takes place at all the temperatures, even at room temperature. However, the speed of evaporation, the rate of evaporation will be less at low temperature. At room temperature, it will be more at high temperature. Now, when there is evaporation, there is cooling. Evaporation results into cooling. Why? Because for the evaporation, the energy is required and the energy is taken from the surface. Like just we put a drop of spirit on our hand, we feel sensation of cooling because the spirit droplet takes up the heat from the skin to convert into gas or vapors, and hence we feel sensation of cooling. Now evaporation is surface phenomenon. It is surface phenomenon. Surface phenomenon means the outermost layer. Evaporation can never take place from the inside of liquid. If we have liquid, say here there is a beaker, and in the beaker there is say water. So evaporation only takes place from the surface. Now evaporation is affected by air speed, or speed of air. So if air is more, then the vapors of the liquid goes very easily from one place to other place, and as a result evaporation will be faster in case of air. Then it depends on the surface area. Depends on the surface area. More the surface, more evaporation. Less the surface, less evaporation. And I'm putting a question. We are able to sip hot tea easily, from a plate than that of a cup. Than that of a cup. With respect to, we can sip or drink tea or milk easily from the plate than that of the cup, because just in case of plate, the surface is more. Suppose I am going a plate, so here something is here. This is tea in a plate. So here more surface area, and so it will be evaporated easily. It will lose the temperature easily. And if I am going to draw a cup, and so cup has less surface. See, you can compare just half. So cup has less surface, and so it will be not able to lose the moisture easily, not lose the temperature easily, not able to evaporate the moisture, and as a result we are unable to sip easily from a cup. So this is a very important point about the evaporation. Now I am going to take next very important point, the boiling point. Boiling point is the temperature at which the vapor pressure of a liquid becomes equal to its atmospheric pressure. Boiling point may be defined as the temperature at which vapor pressure of a liquid becomes equal to atmospheric pressure. Is that clear? Now its unit is Kelvin. It can be measured in degree Celsius. And why we say, most of the persons who are not of the science background, they say boiling point is the temperature at which a liquid boils. So this definition is okay for the small students, just 6, 7. But in 9th onwards, you have to keep in mind boiling point, the temperature at which vapor pressure becomes equal to atmospheric pressure. It is very important to know. Vapor pressure means the pressure of the liquid which is boiling. It is equal to atmospheric pressure. So atmospheric pressure is something, the pressure created by the atmosphere. All of you must be knowing that food materials are cooked very easily in a pressure cooker. But when we take a case of a open vessel, let it be kadahi or bhagoni, so it takes very much time because in the pressure cooker we close with a lid, and lid is compact. Lid has the rubber gasket, and so it creates very high pressure, and as a result the food materials are cooked. But in case of open vessel like kadahi or bhagona, the vessel is totally open. Even if you close with the lid, always there is a possibility of coming out from the sides, and so it is unable to cook easily.